All right, so we're ready to start talking about actual algebra, and it's just going to be an intro. And the basic new feature of algebra is the idea of variables. Okay, and so what is a variable? They're really just symbols, but the symbols that we usually use are letters, and I'll explain why in a minute. So let's just think about variables as being letters used to represent numbers. And so a very common question I get in basic algebra class is why the heck would we even want to do that? Why do we want to use letters to represent numbers? So there's three basic uses of variables that I'll explain. Okay, so the first use of variables is just to illustrate general concepts that apply to either all or maybe a large set of numbers. Okay, and so just to illustrate that, remember before I told you that 1 times anything is equal to itself, right? So that's just a basic property of numbers. 1 times anything is equal to itself. First of all, this is a little confusing because I'm using two different words. Also, it's just a little bit long to write this. And that's one thing about mathematics and mathematicians is they don't like to write repetitive phrases or words over and over. And so that's one reason that people started using variables. And so one way to write this is instead of writing anything in itself, I could just use a letter to represent that. So I could say that 1 times n is equal to, well, what would itself be? It would be n, like that. And so that's just a general concept of multiplication, that 1 times some number is itself, okay? And so that's an idea right there, all right? And so one use of variables is just to illustrate general concepts. And so if you think about it, another general principle that we've seen is 1 raised to any power. So I could write anything, but instead I'm going to use a variable here. 1 raised to any power is equal to 1, like that. And so that's another general concept that we can illustrate with variables. Now make sure you realize too, I'm using the letter N, but we actually have 26 letters to choose from. So I could just as easily have written that concept right there as 1 times B is equal to B. All right. And now one thing about using letters, I could also just use some symbol. I could say 1 times, and I could use that pound symbol that people often use for a number equal to a number. And so what happened historically is people were just using a symbol to represent something. But once alphabets were developed, we had a set of symbols. In the English system, we have 26 symbols, i.e. the letters. And so all those letters really are, or they're just some symbol to represent a number. And we just use the alphabet to do that. All right, and so the second use of variables comes from the actual word variable. Notice that the root of that word is vary. And so variables are things that can vary or things that can change. All right, now don't worry too much about where I get this or anything like that, but I'm just going to show you an example here. So say I tell you that the charge at some shipping store, we'll see, I'll do examples of this all the time. So I'm going to use the letter C to represent the charge at some shipping company where you ship packages. And I could tell you that the amount that they charge is equal to 1.75 times W plus 2.10. Like I say, don't worry too much about where that comes from. Okay. Now, one thing too to point out is remember sometimes we explicitly use a multiplication sign. Sometimes if we write two numbers next to each other, like that, that's called juxtaposition. And that also means to multiply these two things. We'll see that often, okay? And so I tell you that the amount that the shipping company charges is obtained from this equation right here, all right? So what can happen? Whenever you go into that store, I didn't explain the W, and so W here is equal to the weight of the package. Okay, like that. And so what happens whenever you go to the store? One day you go in and you ship a package that maybe weighs 1.2 pounds. All right, but then another day you go and ship another package that weighs maybe 5.6 pounds or something like that. So that weight can vary. All right, and so what one use of these expressions or use of variables allow us to do is I can look at the charge that I'm getting for different weights. All right, and so this W can vary, and then we can compute this, and I'll talk in just a minute about how we do that. You could probably see, but just in case, I'll go over that. All right, so all I'm pointing out right now is that that's a second use of a variable. One use is to illustrate general concepts. Another use is to have some quantity that can change or vary, and look at what happens as that variable does change. And the third use is you're most familiar with. The third use is to find some specific but unknown number, and that's the idea of solving equations. And so, sorry about that. I could have something like this. Okay, this is called an equation. We'll talk about this more later, but an equation is something stating that two things are equal to each other. Okay, and so here I have some variable x, all right, and it satisfies this equation. There's only one number that satisfies that equation right there. And so x can't be any number whatsoever like it can be whenever we use it to illustrate a general concept. And so this is one specific number here. Now we'll talk about this later, so don't worry about it if you don't see it. But actually x equal to 5 is the only number that satisfies that equation. And so then in that case, the variable is just one specific number. But before I told you that x was 5, we didn't know that. It's not obvious just by looking at that x is 5. And so we'll talk later about how to actually do some mathematical work to figure out that number. Okay, so we're going to look at that second use of variables and talk about different ways that we can use it. Okay, so now looking at that second use of variables, it involves this term called an expression, or some people write an algebraic expression. Okay, and so all an algebraic expression is it's a combination of numbers, variables, and operations. So remember the operations that we know are add, subtract, multiply, and divide. Also exponents are considered powers. And also remember too, there's different ways to write multiplies. We can use the dot, or we can use that juxtaposition idea. And then remember divides, sometimes we write the division symbol, or sometimes we use a fraction bar to do that, okay? And so an expression then would be something like 2x plus 5, okay? Or I could have 3 times, I could use the letter A, so I could have A plus 7 in parentheses minus 4, like that, okay? And so those are called expressions. And one thing to keep in mind, too, is notice that there's no equal sign initially in the problem. Whenever we put an equal sign and another side to that, that's called an equation that we'll talk about in a moment, okay? Now, what we often do, just like with that weight example earlier in the video, is often we evaluate an expression, okay, like that. And so what that phrase means is that we plug certain values in for the variables, okay, and so certain values for the variable. And sometimes there's more than one variable, so I'll put an S in parentheses there. So we plug in certain values for the variable, and then we just use order of operations to compute the result, okay? So let's look at some examples of that. Okay, so what we're going to do is, in a moment, I'll give you an expression. So this is what I mean by the given expression. We're going to evaluate the given expression for x equal to 8. Okay, so what's going to happen here is, let's look at our first example and say the expression is 2x plus 5, like that. Okay, so this is an expression. It has numbers, variables, and operations. Remember, there's an operation here meaning times. And now what does the directions mean? This means that x is going to equal 8, so I want to put 8 in here. Now this is something that's really important for later, is what I do, now first of all realize if I write this, you might get confused and think that that's 28 times 5. You got to remember that that's a times right there, okay? So you could do it that way, but this is very important for later, is what I tell people to do all the way, even in calculus classes. Anytime you're filling numbers into an expression, fill them in parentheses, okay? And so in our first bit of homework, this won't be terribly important, but it's a good habit to get into, because whenever you fill negative numbers into expressions, things can get a little bit complicated, and you can make sign errors easily. So the way I do this is, if I were doing this homework problem, I would start here, and I'm going to fill in x equal to 8, but I'm going to fill it in parentheses. Okay, and so now remember that that's juxtaposition, so that is a multiply. Now the other important thing too is, once you get to this step where you filled things in, follow order of operations. And so what do I have here? I have a multiply and an add. So I multiply first, and so I get 16 plus 5, and then I add, and so then that's 21. Okay, so let's do one more here. Say I have 3 parentheses x minus 2 plus 1 plus x. So here I have x in two different positions. Okay, and so I'm going to plug in x equal to 8. Now notice here that x is already in parentheses, so I don't necessarily need it to put a second set of parentheses there. So I'm just replacing the x with the 8, okay, and then plus 1 plus x, so that's plus 8. Okay, now I follow order of operations, and so remember, order of operations say to do parentheses first, so I do that 8 minus 2. That's 3 times 6 plus 1 plus 8, okay, like that. And then I have multiply and 2 adds. Multiply, add, so I do the multiply first, and so that's going to be 18 plus 1 plus 8. Then I do my 2 adds. I'm running out of room here, so I have 19 plus 8, and so I get 27 as my answer. Okay. One small thing too, try to get into the habit whenever you do problems. You can see sometimes I forget and then I go back and do it. Try to get in the habit of circling answers. It just makes it easier for you and usually your teacher to see where you ended up at. Okay. Now expressions can have more than one variable in them. All right, and it works just the same. So let's just do some examples, just like the last one. So say I tell you to evaluate the given expression for x equals 4 and y equals 3. All right, so I have to give you some expression that has x and y in it. So I could say x plus y minus xy. Okay, and so that looks a little bit complicated, but we do things just like we did before. The only thing is we have these two different variables and they have different values. X is going to equal 4 and y is going to equal 3. All right, and so what do? I plug in 4 for x, okay, plus 3 for y, and then minus x is equal to 4 times y, which is equal to 3. All right, and then again I follow order of operations, so I have 4 plus 3, and then the reason I did that is I have this multiply here, so that's what I do first with my order of operations. So 4 times 3 is 12. Okay, now I have an add and subtract, so remember those are on the same level of precedence, so I go left to right, and so I get 4 plus 3 is 7 minus 12, and then hopefully you're comfortable with your sign numbers by now. 7 minus 12 is negative 5. Okay, and so then let's do another one after I circle my answer. All right, and say I have x parentheses y plus 2 minus 3x plus 4y. Okay, so this one looks pretty complicated, and it is a little bit, but we just progressed. Remember that x is equal to 4, so I have 4 times y is equal to 3, so I got 3 plus 2 minus 3 times x, which is 4, plus 4 times y, which is 3. Okay, like that. All right, so I do parentheses first. Notice those single numbers in parentheses. That's just from filling in. We don't have an operation. Here's where I have parentheses in my order of operations. So I have 4 times 3 plus 2 is 5. So I have 4 times 5. Here's another multiply. So I have minus 12. And then I have another multiply. That's plus 12. Okay? And so let's see if I can just do this. There we go. Sorry about the overlap. But, and so now I still have a multiply here. So I got 20 minus 12 plus 12. Now, you can just go left to right like we always do. I will tell you adding and subtracting, you can go in either order. So if you notice that right here, negative 12 plus 12 is going to give you 20. Negative 12 plus 12 is going to give you 0. And so you could take a little shortcut there. I'll just follow our normal thing and go left to right. So we have 8 plus 12, and 8 plus 12 is 20. So let's look at some examples with exponents. Okay, so we'll just look at one expression here. So we have this expression, x squared plus 2x plus 1. So these directions are a little bit different. In the last ones, I was giving you the value of x, and I was giving you different expressions to play with. Now let's have just one expression, x squared plus 2x plus 1, and we're going to evaluate that for several different values of x, which is a more common way to do this. And so, for part 1, let's do x equal to 3. Okay, like that. And so what you do is you take your expression, x squared plus 2x plus 1, and then I'm going to fill in that value of x. And again, I highly encourage you to use parentheses whenever you do that. So we have 3 squared plus 2 times 3 plus 1. Okay, and then, so now remember, order of operations says to do exponents first. So I do that 3 squared first. So I have 9 plus 2 times 3 plus 1. Okay, now I have 2 additions, and you see that this is a multiply right here. And so I do the multiply first, so I have 9 plus 6 plus 1. All right, and then now I have these 2 adds, so I go left to right. 15 plus 1, that's equal to 16. Okay, like that. Now, one thing that's very important here, let me try to get all this to move because I'm kind of out of space. All right, so this is where those negative or those parentheses are important, especially whenever you plug in negative numbers. Okay, you should use parentheses because it's really easy to make sign errors. All right, but otherwise it's just the same way. I have x squared plus 2x plus 1. You might want to pause this and try this to see what you get, and so you can see that it is easy to make mistakes. So why don't you try that and just see what you get. Hopefully you did pause and try. I'm going to go ahead and move on though. So again, I use parentheses, okay? Now I'll explain why that is very important in this problem here, and especially if you did this wrong. Now if you remember too, I told you that I don't mind if you use your calculator to do these calculations, okay? And so feel free to do that, but the key thing is, in these cases, you have to use those parentheses. And what will happen is if you just type in negative 3 squared, remember we talked about this in an earlier video, that's going to come out as negative 9, okay? And so if I have that negative 3 in parentheses, that means I'm squaring the negative 3. So I'm doing negative 3 times negative 3. That's equal to positive 9. So I get 9 plus 2 times negative 3 plus 1. Now I do my multiply, so I get 9 plus negative 6 plus 1. Remember that plus a minus I can rewrite as a subtraction right here. So this is really 9 minus 6 plus 1. Now I go left to right, I have 3 plus 1, and that's equal to 4. And so hopefully you got that. If you didn't, I would guess that where you went wrong is this part right here that I just talked about here. All right. You may have missed your sign there too. I'm not really sure. All right. An important part about all this deals with what are called equations and solutions and checking solutions. Okay. So first of all, whenever you see this term equation, all right, that's different than an expression, and it'll be important as you go through different math sections or classes to distinguish between what makes something an expression and what makes it an equation. because there's different things you can do with an equation that you can't do with just an expression. But what an equation is it's a statement that two expressions are equal, okay? And so equations are composed of two expressions, okay? And the key thing is you're saying that they are equal, okay? And so one way to think about that is that the problem comes with an equal sign, okay? And so that's the key thing. Now, one thing to point out is basic arithmetic involves equations. And so I can have something, I had 2 plus 3 equal to 5. That's an equation that's true. And so we would say that that's a true equation. Okay, I could mess up. I could say that 2 plus 3 is equal to 9. Okay, and so that is an equation because I'm saying two things are equal, but that's a false equation. Okay, EQN, by the way, is my abbreviation for equation. All right, and so you can have equations that aren't true. They're false, okay, and that ends up being important in this idea of what I was talking about, checking. Now, most equations that we're going to deal with have variables in them, so they're not like this. And so I'm not going to write a separate line, but an algebraic equation would be an equation with a variable in it. Okay, and sometimes later on we'll see ones that have even more than one variable. Okay, and so I'll put it here. An algebraic equation would be something like 2x plus 3 is equal to 15. Okay. Or something like 3 times x plus 2 minus 1 is equal to 4x plus 8, something like that, okay? And so those are called algebraic equations, all right? Typically, there is only one value of the variable that would make this equation true. So remember, there's this idea of a true or a false equation. All right. We'll see later, and especially if you go to other math classes, there are equations that have more than one number that satisfies it. Okay. So that leads into the idea about what we mean by a solution to an equation. Okay. And the solution to an equation, what that is that's a number, a specific number that when substituted into it, just like we did with our expressions. Okay, and so remember we were talking about evaluating. Whenever we plug that number in for the variable, we say we're substituting it. And so it's a number when substituted, that's going to give a true equation. Okay, and so if that's not really clear, I'm going to show you some examples in the next thing. Okay, whereas sometimes we think we have a solution, but we go and substitute it in, and it'll give a false equation. And so, and then in those cases, the number would not be a solution. All right, I'm going to write these examples in the form that your book gives to you because it's a little confusing. So partly I just want to explain what they're getting at here. But what we're going to do right here in these examples, we're going to determine whether the given number is a solution to the equation. Okay, so look at the format of this. Right here, this is an equation right here on the left, and then it gives a semicolon and gives you a number. Okay, so what that is, this is the proposed solution right here. All right, and so the idea here is that you substitute the given proposed solution into the equation and then see if it's true. Okay, so if it gives a true statement. So that's what we're going to do if it's not clear. Now in this problem right here, notice on the right side there's only a 15, so there's no variable over here. Sometimes the variable will be in both sides, and so you got to plug that proposed solution into both sides. Now let me show you the best way. What we'll see later is once we talk about how to solve equations, we'll actually do some mathematical steps to produce this number. Where this is going to come in handy later is we'll want to make sure we did all our work correct. So this ties into the idea of what's called checking. And so this is what we'll do whenever we try to check a solution to an equation. But we're starting here, and let me show you what I kind of got on a tangent there. And so what we're doing is we're wondering if x equals 6 is a solution. Okay, is what we're doing. All right, so different people have different ways to check, but it can get kind of confusing. All right, so what's going on here is I'm substituting x equal to 6 into my equation. So remember to plug it in parentheses like that. Okay, now right now we don't know if this is true or not. So what I do is I write a question mark. We're wondering if this is true. All right. If I don't write that question mark, we're kind of writing that it is true whenever we're still trying to determine if it is true. All right. Now remember, now what you're going to do here is you're going to follow order of operations on both sides of the equation. This one's a simple one to start out with because there's only a number over here on the right. So all we have to do is keep writing this 15. And so over here on the left, we follow order of operations. So we do that multiply first, that 2 times 6, 2 plus 3, 12 plus 3. Some of you might already see whether this is true or not, but go ahead and follow it all the way down. So here we're still technically wondering, but then I do that 12 plus 3, and 15 does equal 15, okay? And so yes, here, x equals 6 is a solution, all right? Now, so that's the idea about what we're trying to do. All right, so here's our next 3 examples. If you're feeling comfortable and you want to try to see if you can determine whether or not these are solutions, why don't you go ahead and pause, try it out, or maybe just try it anyway just to see if you've absorbed it or not and see how you do. Okay, so hopefully you did pause and try them out, but I'm going to go ahead and carry on. So again, remember this weird notation. If I were writing this book, I would have written these differently, but here's my equation, and then there's a semicolon, and here's the proposed solution. All right, and so the idea here is we're on this one, we're wondering if x equals 4 is a solution. Okay, SOLN is my abbreviation for solution. I abbreviate a lot. So anyway, we're plugging x equal to 4 into this equation. So I'm plugging x equal to 4. Remember, and if x is in both sides, I do it on both sides. All right, and so I get 3 times 4 plus 5. And again, we're wondering if that equals 11. All right, and so this is like the last example. You want to do the multiply first. So we have 12 plus 5. We're wondering if that equals 11. On the left side, though, 12 plus 5 is equal to 17. That does not equal 11. That's not true. And so the answer on this one is no. 4 is not a solution. Okay. You can't answer these questions yes or no, by the way. But make sure to show work and make sure I can see that you actually determine whether or not it is a solution. All right. And so then here on problem 3, here's my equation, and then I'm wondering if x is equal to 5. Okay, and so that's what we're wondering here. And so I'm going to plug x equals 5 in. Since it's already in parentheses, I don't necessarily need to put that in parentheses. Again, it gets a little confusing with so many parentheses. And so we're wondering if that left side is equal to 14. All right, and so we do parentheses first, following order of operations. So we have 3 times 6 minus 1 equal to 14. We're still wondering. Okay, then I multiply. I have 18 minus 1 equal to 14. You can probably see that they're not, but let's just say we're still wondering here. And so then we get 17 equal to 14. So that's not true. Okay, so no, x equals 5 is not a solution there. All right, and then for our third one, notice that, or our fourth one, sorry, notice that x is on both sides of this equation, and we're wondering if x is equal to 7 is a solution. Okay, and so that's what we're wondering. So again, I plug it in on both sides. 2 times 7 minus 1 plus 3. We're wondering if that is equal to 7 plus 8. Okay, so if you want, you can think about this as being the evil math teacher's way to get 2 order of operation problems in one problem. The key thing is I do the left side like it's its own expression, and then I do the right side like its own expression, and then I see if those 2 numbers are equal to each other. Okay, so on the left side I do my parentheses first. 7 minus 1 is 6, and so I have 2 times 6 plus 3. All right, and I do my multiply, so I have 12 plus 3. And so on the left side, I get 15. Okay? And on the right side, I have 7 plus 8. Maybe I worked a little bit too far ahead there. Maybe I should have done one line at a time. But anyway, so I would have just written equals 15 with question marks. But then I finally get it down to where 15 does equal 15. And so that is a true statement. And so, yes, x equals 7 is a solution to that equation. Okay, so that's the first basic use of variables that we're going to use extensively. That first use that I listed to illustrate general properties is important, and then, but that'll be more stated in the lecture material or in the book material reading. But as far as the first purpose that we're going to use it for, we're either going to be evaluating expressions with variables, or we're going to be checking equations, and that involves evaluating expressions. Okay, so I hope that helps, but as always, feel free to let me know if you have questions.